See, and then the other thing is I'm admitting you all and it's still saying y'all in the waiting room. But I see you. You're in. Crazy, crazy. Technology, technology. So many things have changed with my Zoom. And right now, normally I can access the video from your playlist. And for some reason, I don't have access to that anymore either.
Hey everybody, it's Mr. Smith.
All right, so I had to cue you up from YouTube instead. All right. Um, Abigail. Yeah, I did the gizmos the other day. You, Abigail, you also, did you go back and do the quiz? Let me check. You might have sent in the gizmo after I already graded. So, okay, I see you submitted that part. Did you go on, did you finish the quiz after there's a 5-question quiz that was after the assignment. Abigail, did you do that? Because I'm showing that you, at the time that I looked at it, you had not done that. Do you know if you've done it? I see that you submitted this, but that's the worksheet. Um, and Natalie, you too, I did, and Shakobi. At the time that I did the grades for the 3D worksheets, the 3D lab, you had not done the quiz. And I'm asking because I have to go back into the gizmo. Okay, so I will go back into the gizmo and I will upgrade that. And I will do that after we do 4.9. All right, so I did have a couple of folks that got 0 on that part, on the 5-question. So you have two scores. You have a score out of 4 and a score out of 5. So like I said the other day, I did go through all the ones that I had. And so if you have a 0, that's because at the time when I graded them, there was nothing to grade. So I will go through today and I will upgrade all those that need upgrading. Okay. All right. Most of y'all are in, and I do want to give credit to those who are here on time. So I'm going to go ahead and get started because, again, we do need to keep moving. We have a lot to do before May to cover all the bases. The 4.9 is the last unit in this, and unit 4. So today is, we'll cover that. You have 2 assignments to, excuse me, the El Nino La Nina assignment is open. I kind of opened it at the end of the class the other day, but a lot of you were still working on other things. I really wanted it for today. And then the FRQ question that he posed for 4.8, and the one he's going to pose today for 4.9. So both of those are now in queue on your assignment list. Okay, so you got a few things to do today, as well as I'd have a few things to do, is to go in and catch up on all these folks who need me to catch them up. All right, some of you also have a 0 for the AP classroom for 4.6 and 7, and now we're on 4.8 and 9. So this is the last 9 weeks, folks. We don't have time to start falling behind. So please try to stay on top of what's going on. All right, that being said, that's enough soapbox for one day. So I'm going to share my page and share the video. It is in your playlist. Like for some reason now I don't have access to that button that lets me go from your playlist to show what's there, but according to my YouTube page, it's on your playlist. So, okay, why are we not sharing? Like I said, all my buttons have changed. I don't know why, but I am going to get to the bottom of it before I see you next time. All right, so Mr. Smee. So so like I said, I had wanted the El Nino La Nina thing to be for today's because that's the topic he's covering today. So if I can get him to start. I always have this little green button in my way. And I cannot get to. Oh, I can drag it to, and I dragged it to move it out the way and it came right back. Ah, there we go.
Called the El Nino Southern Oscillation. So this is a periodic shift in atmospheric pressure, wind patterns, and ocean temperatures in the Southern Pacific. And so it's a cool way to end this unit because it builds on a lot of the other topics from Unit 4. Our objective for the day is to be able to describe the environmental changes and effects of El Nino and La Nina events, which are the two extremes of the Southern Oscillation pattern. In order to do that, we need to know that these events involve changes in the Pacific Ocean surface temperature, global wind patterns, and ocean currents. We also need to understand that they're influenced by geological and geographical factors, and that they have different environmental impacts on different areas. Our suggested science skill for today is to describe environmental problems. So before we get into El Nino and La Nina, we have to look at some global ocean surface current patterns. So the first thing we'll discuss here is a gyre. A gyre is a large ocean circulation pattern that happens because of global wind patterns, and in the northern hemisphere they're going to be clockwise.
Well, that's quick.
Because of Rossmed, I am ready for it all.
Whereas in the southern hemisphere they're going to be counterclockwise. So let's take a look at how global wind patterns cause these gyres to form. If we look on the map here, we'll see that between 0 degrees and 30 degrees, wind patterns are going to be moving water along the equator from east to west. Whereas when we get up to 30 degrees, between 30 and 60, we're going to have westerlies, which are going to blow these ocean surface waters from west to east. So we get these predictable patterns of clockwise rotation of surface currents in the northern hemisphere and counterclockwise rotation in the southern hemisphere. And again, that's based on the prevailing wind patterns that are going to move ocean surface waters along the equator from east to west. And then as they start to move northward, they get directed by bodies of land. Then they get to 30 degrees where they switch directions from west to east, and they're just repeating these cycles here. There's another important topic we're going to talk about here in this map, which is upwelling. So if we look at these blue areas, we'll see upwelling zones. And these are areas where we have warm surface waters that are moving away from a landmass. So here we have warm surface water moving away from the coast of South America, here from the coast of North America. And what this does is brings colder water up from lower in the ocean to replace that warm surface water. Now the benefit of that is it brings up oxygen because cold water holds more oxygen than warm water. It also brings up sediments from deep in the ocean though, which have nutrients. So along these upwelling zones, we're going to see really productive fisheries. These are really productive fish populations where people will often make sources of income by catching the fish or have sources of food. And before we move on, there's one final thing I want to call your attention to on this slide, and that's this region of the Southern Pacific here. So this area outlined in yellow is where we'll be focusing today. So I want you to remember that during normal conditions, we have eastern trade winds that are blowing these surface waters from east to west. And so that's going to move warm surface waters over towards Southeast Asia and Australia. And it's going to lead to this upwelling, which brings cooler water up to the coast of the Americas. That's going to be really important to understand when we go forward to discuss what happens during an El Nino and La Nina event. Now we'll talk in a little more depth about the global mixing of the oceans. So the thermohaline circulation is this movement of ocean currents that connects all of the world's oceans and mixes salt, nutrients, and temperature throughout all of them. So as we discussed in the last slide, warm surface water moves east to west along the equator and then up into the Gulf of Mexico, where it warms further. Then as it gets up to the 30-degree latitude, it's going to be blown back from west to east by the westerlies. So as it moves back towards Europe, it's channeled up towards the North Pole. So as this warm Gulf Stream flows north, some of the water evaporates, making it more salty since the salt can't evaporate with the water. It also cools and becomes more dense so that by the time it reaches the North Pole, it's much more dense due to both temperature and increased salt concentration. This causes it to sink. So if you look at the diagram on step 2, we're switching from a red arrow to a blue arrow to signify that this water has sunk down to the ocean floor, where it's going to mix around and spread out all over the ocean floor. So this is important because it distributes the salt in the ocean and the sediments, which have nutrients, and it even mixes the temperature of the ocean. What happens though is eventually this cold, deep water is going to have to come back up to the surface, especially at these upwelling zones, where it's going to replace the warmer water that's being blown away from a landmass. This is going to bring up colder temperature, nutrients and oxygen with it, and again, it just contributes to this global mixing of the world's oceans. The thermohaline circulation also has an important implication in moderating the temperature of different areas of the Earth. So if we look at step 1 here, where this warm water from the Gulf of Mexico is moving northward, and then it starts getting blown from west to east by the westerlies, and moves up past Europe, it's going to bring some of this warm air that it's carrying and deposit it over Europe, which is going to make the climate of Europe far warmer and much more moderate than climates at the same latitude that we find over in Canada. And so that's one way that this thermohaline circulation has an important effect on the climate of different regions. So now with the basics of global ocean circulation down, we can move on to ENSO, or the El Niño Southern Oscillation. So there's the tendency to simplify this concept into just an El Niño or La Niña event or normal conditions, but it's called the Southern Oscillation for a reason. So as we can see in the graph, what we really have is a constant fluctuation or oscillation back and forth between El Niño conditions, which bring warmer, rainier conditions to South America, and La Niña conditions, which bring cooler, drier conditions to South America. So I also want to point out that El Niño and La Niña events don't usually just happen solely in one year. So we call them events because they might peak in a given year, but they usually grow and then weaken over the course of a few years. So before we talk about an El Niño or a La Niña event, I just want to review the conditions that happen during a normal year, or the neutral conditions. So normally we have trade winds that are going to blow from east to west in the equatorial region. And this is going to move the warm surface water of the ocean towards the west. It's going to shift it towards Australia and Southeast Asia. And because warmer water and warmer air has more moisture, that's going to lead to higher precipitation in this region. That also pulls cooler water up from the depths of the ocean to replace this warm surface water. And we can see that upwelling effect here. When the warm surface water is blown from east to west by these eastern trade winds, it's going to pull colder water up to replace it. Remember, colder water holds more oxygen. It also brings up sediments, which have nutrients. So that's why the coast of South America here is going to experience really productive fisheries during normal or neutral conditions. Because we have this warm air mass over here, that's going to be rising and expanding. This is going to create a low pressure system in the west, and that air is going to expand and sink back down and create a high pressure system over in the Americas. And that's what continues to drive these trade winds in the east to west direction. Now we'll look at an El Niño event. So the major indicator of an El Niño event is that the trade winds are weakening and they're actually going to reverse their direction. So they're no longer blowing from east to west, but they're going from west to east. What this does is shifts the concentration of warm surface waters towards the Americas. Now we're going to have cooler than normal conditions in Australia and Southeast Asia. Because of that, there's less rain, so we're actually going to see drought-like conditions potentially in Australia and Southeast Asia. This warmer water being shifted towards the Americas gives us milder winters in North America, but it's also going to lead to much rainier and warmer weather in the Americas, which can lead to flooding. And the big problem, especially in South America, is it's going to suppress the upwelling. So notice with this warm mass of surface water, we don't have that upwelling of the cold, deeper ocean water. So that's going to be a problem. It's going to really shut down those productive fisheries, and it's going to be really harmful to people that rely on fishing as a source of income or food, especially along the coast of South America. And lastly, we'll take a look at La Nina conditions now. So La Nina conditions are going to be stronger than normal trade winds. So this sees a reversal of the trade winds back to our east to west direction. And so that's going to shift the warmer surface waters back over to Australia and Southeast Asia. It's going to lead to even warmer than normal conditions there and even rainier than normal conditions there. So we may see flooding, we may see more intense monsoon activity in Southeast Asia, and it's going to lead to increased upwelling off the coast of South America. So in the Americas, we're going to see cooler than normal weather. We're going to see less rain and less precipitation than average, and we're going to see especially productive fisheries due to this increased upwelling effect. So here we have a summary of the effects that El Nino and La Nina can have on different regions. So a really important takeaway from El Nino is that it brings warmer surface water to the west coast of the Americas, and that suppresses the upwelling of cold, deeper ocean water, especially in South America. And this can be devastating for fishermen who depend on the productive fisheries, and for farmers who can often lose crops due to the flooding that's brought on by the especially rainy El Nino season. Farmers in Southeast Asia and Australia, meanwhile, may experience droughts due to the decreased rainfall that they see as the warmer Pacific waters are blown away from them and towards the Americas. Two positive impacts of El Nino, however, are that they typically weaken hurricane activity in the Atlantic, and they typically weaken monsoon activity in India and Southeast Asia. This also leads to typically a warmer, more mild winter in North America. La Nina, on the other hand, brings especially cold weather to the west coast of the Americas. This can lead to less precipitation in the Americas, and it can also increase tornado severity in the US and hurricane activity in the Atlantic. Southeast Asia sees a return to the rainy conditions they're used to, which can be beneficial for agriculture, but it can also bring extreme flooding and an extreme increase in monsoon activity. All right, everybody, our practice FRQ for topic 4.9 today is to describe an environmental problem. So I'd like you to see if you can describe two environmental problems related to the conditions of an El Nino event. All right, everybody, thanks for tuning in today. Don't forget to like this video if it was helpful. Subscribe for future APES video updates.
Okay. So, where is it now? All right, I wanted to, all right, this thermal haline circulation is extremely important. And if you are lovers of the movie Finding Nemo, this is the circulation pattern that they were swimming through, that everybody had to get on that conveyor belt with the water moving, and they had to jump in and jump out. This is the belt that they were talking about in Finding Nemo. One of the things I like about Disney is they always try to put in realistic, hold on, I'm trying not to be in my grade book. Let me stop sharing for a minute because that's where it's going. Oops, okay. All right, so back in Canvas. So you have two assignments on your home page and in the module. Now I can get back over here. You have one that was the El Nino assignment, and the other are the FRQs that he shared, the one that he shared today and the one that he shared the other day. So the first one, all right, so you're going to define what is El Nino and what is La Nina, and then you're going to answer the question, thinking about the weather conditions that we've had this year. And then this is a research question. This is not going to be in Canvas. These two you can get from Canvas. This one you're going to have to look up because we want it for current. So not necessarily about a La Nina or El Nino year, but what events are we in this year and what are we transitioning to? and what are the conditions or the predictions that are going to follow based on whether that we're in El Nino or La Nina. So we are transitioning at the moment from one to the other. So you want to discuss that. There's also the include the name of the agency. It's not NASA that is responsible for tracking this information. Okay, so that's the first assignment. And the second one is the FRQs. All right, so this is for the 4.8. So you want to enlarge that somehow and and describe the regional precipitation pattern. Remember last class he talked about mountain ranges that are formed by subduction zones. And on one side of the mountain, you have one type of weather condition. On the other side of the mountain, you have another type of weather condition. So that's what they want you to discuss in this particular question. And then he took the time to, at the end of the video, to kind of elaborate on how he wanted you to answer that. So you might want to go back and rewatch that video. And then this is the question today. Name 2 environmental problems. So basically weather patterns that evolve because of El Nino. And he also mentioned the fishery situation. So you might use that as one of the 2 events. All right. So that's what you need to work on today. And again, the AP Classroom is open for both of those units, but work on this first, please. And while you're working on that, I will go back, and those of you who say you did other grades, I will put those in as well. So I will check on those and add those. I do see some submissions for the lab, so I'll put those in, and I'll go back and on the website and look for the quiz grades. All right, any questions? Any questions? And again, I don't have focus mode, so you are visually on the videotape. So if you don't wish to be visually on the videotape, you should turn your camera off. Okay, thank you. I will record those and take care of that right now. I'm going to do attendance first. Every time I do it after lunch, they always want you to authorize to get into the Infinite Campus. All right, and he mentioned some words, geysers, upwelling zones, and thermohaline circulation. Make sure that those are vocabulary words that you tuck away because you need to use them. And being as a lot of this unit ties all together, I'm going to do the progress check in the AP Classroom as opposed to doing a separate Canvas test for 4.6 through 9. So I'll do the whole unit test, the checkpoint test in AP Classroom, since so many of the topics overlap. I say that to say this, to go back and check on previous sections if you finish up and have the time, so that you can relate the topics together when it comes time to doing the test. I have all kinds of little notes here. When you're discussing the 4.8, make sure you use terms like rain shadow and climate seasons and what direction the winds are traveling in. She is not. It is. All right, so at this time on the Gizmo page, I have quiz scores for everybody except Brooklyn and Kayla. So you might want to go in and do that quiz, please. And if I've already graded your assignment, I will go in and upgrade it with your quiz score. I've already updated it. If you refresh your page, you'll see it's been done. And I'm still in the process of, this person's not here today, but I'm working on theirs. But for most of you, yes, I've already updated your grade. And I do want to say, folks, that the reason why the grades turned up being 0 is this was an assignment that was given way last week that should have been done. And I moved the due date back because we were out of school on Monday. So I gave an extra day, but the zeros had already gone in because that's what the grade book does. I don't go and put zeros in. The grade book does it according to the due date. So even though I changed the due date, it did not take out the 0. But it is not late, or I'm excusing the late in most cases. If you haven't already answered the question for La Nina and El Nino, again, include what weather pattern they are predicting will happen the rest of this year because of what season we're going into. Wow. Okay, folks, it is time.